Hello, today we'll understand how to solve a linear system by the method of elimination. So let us first look when we should use the method of elimination or when is the method of elimination preferred. So I'm going to take a linear system over here. Our linear system is 5m plus 2n is equal to 5 and 2m plus 3n is equal to 13. In this linear system, you can see that none of the variables are without a coefficient. So they all have a coefficient other than 1. So it is not easy to isolate for a variable and go ahead with the method of substitution, and that's the reason we'll use the method of elimination over here. Now to do that, we need to eliminate either m or n. So let us try eliminating m. And for eliminating m, what we have to do is we have to make its coefficient the same. So here the coefficient is 5 and here the coefficient is 2. So we can make the coefficient for both of them 10, and in order to do that, we'll multiply this whole equation by a 2, and this whole equation can be multiplied by a negative 5. And why we are doing that? Because we need to have one coefficient positive and the other coefficient negative, so that when we add them together, that specific variable gets cancelled out. Let us see how it works. So our first equation turns out to be, we're going to multiply each term by a 2. So it is 5 times 2, 10m, plus 2 times 2, 4n, is equal to 5 times 2, which is again 10. Now, in the second equation, we are multiplying this one by a negative 5. So our equation turns out to be negative 5 times 2m is negative 10m. Negative 5 times 3n is negative 15n. And 13 times negative 5 is negative 65. Now, because one of the variables, they have their coefficients same but with opposite sign, so we are going to add these two equations now. When we add the two equations, 10m plus negative 10m, it gets cancelled out. 4n and negative 15n, when you add them together, we are going to get negative 11n, and 10 plus negative 65 gives us a negative 55. To isolate for n, we need to take this negative 11 on the other side. Here it is in multiplication. On the other side, it goes as division. So n is equal to negative 55 divided by negative 11. Hence, the value of n is equal to 5. Now, we have to solve for m also. And to do that, this n value can be used in any one out of the two equations, the original one. So let us take this equation, the first equation, and substitute the value of n in that. So we have 5m plus 2, the n is being substituted by 5 because we've already got that value, is equal to 5. Now let us try solving it. 5m plus 5 times 2 is 10 is equal to 5. 5m is equal to 5. 10 on the other side goes in subtraction. 5m is equal to negative 5 and m is equal to negative 5 over 5. So we've got the value of m, which is equal to negative 1. Now let us also see if our solution is correct or not. In order to do that, we are going to make a check. So first we are making a check for equation number 1, which is 5m plus 2n is equal to 5. For this, our left hand side, we are going to substitute the value of m and n in the left hand side of the equation. So we have 5 times negative 1 plus 2 times 5, and this is equal to negative 5 plus 5 times 2 is 10. Negative 5 plus 10 is 5. Our left hand side we got it as 5, and the right hand side we can already see that it is equal to 5. So the value of m and n we calculated by using elimination. It satisfies our equation number 1. Now we'll see if this satisfies equation number 2 also. So our number second equation is 2m plus 3n is equal to 13. Now we'll put the value of m and n into this equation as well. So our left hand side is 2 times m is negative 1 plus 3 times n is 5. This is equal to negative 2 plus 3 times 5 is 15, and negative 2 plus 15 is equal to 13. Our left hand side, on substituting the value of m and n, we got it equal to 13, and our right side for this equation is already a 13. So we can see again for the second equation, our m and n values satisfies the equation. So our solution m is equal to negative 1 and n is equal to 5 is the solution to this linear system. I hope you understood and enjoyed the video. See you in the next one. Bye-bye.